Hello everyone, welcome to Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad. This is S. Kumar, working as an assistant professor for the Department of Electrical and Electronics Engineering. In the part of lecture series, today I am going to explain about, today my topic is measurement of active and reactive power in three-phase circuits. So this is my topic. So the table of contents are measurement of power in three-phase circuit, introduction, and wattmeter method, 1 wattmeter method and 3 wattmeter method. So actually for the measurement of three-phase power in three-phase circuits, either it may be a balanced or unbalanced three-phase circuits. So we have different methods are there to measure the power. So one is 1 wattmeter method and second one is 2 wattmeter method. Third one is 3 wattmeter method for the measurement of power in a three-phase balanced or unbalanced circuits. So here in last lecture, I discussed about the method called 2 wattmeter method for the measurement of power in three-phase circuits. As we know that the power is measured, by a device called wattmeter. So the wattmeter consists of current coil and voltage coil. These are the two coils the wattmeter contains. So wattmeter consisting of current coil and pressure coil or voltage coil. So in general, the current coil is connected. The current coil is connected in series with the phase, and pressure coil is connected in between the two phases or between the phase and neutral of a three-phase circuit, depends upon either the load is star connected load or delta connected load. In this lecture, we are going to see another different methods, another two methods. One is 1 wattmeter method and second one is 3 wattmeter method. So 2 wattmeter method already I covered in previous lectures. So what is 1 wattmeter method? So in this 1 wattmeter method, in order to measure the power in a three-phase circuits, only one single wattmeter can be used. Only single wattmeter can be used to measure the total three-phase power in a three-phase circuits. So here in 1 wattmeter method, by using single wattmeter for the measurement of power, the current coil of a wattmeter is connected in series with the phase or any phase. It may be R phase, Y phase and B phase. And similarly, the voltage coil or pressure coil is connected between the phase and neutral of a balanced or unbalanced load. So this is a connection, how we are connecting the single wattmeter method in three-phase, either star or low delta connected load. So current coil of a wattmeter is connected in series with any one of the phase of a three-phase balanced or unbalanced load, and pressure coil and voltage coil is connected in between that particular phase and neutral. So that is a connection of a wattmeter. So in wattmeter method, there is in single wattmeter method or 1 wattmeter method, there is a demerit is also there. So the demerit is there. So any slight degree of unbalanced in the load produces large error in the measurement of a power. So this is the disadvantage or demerit of single wattmeter method used for the measurement of power. So the disadvantage or demerit is, if you are changing any degree, of a unbalancing of a load. So that produces a large error in the measurement of a power. In this method, one wattmeter is used for the measurement of power in one phase. So if you want to get a total power, so we are getting 3 times the wattmeter reading of that particular phase. So the total power is given by 3 times the power in any one phase of a 3-phase circuits. So that is 3 times phase voltage into current into cosine angle between voltage and current. So this will give the total 3-phase power in 3-phase circuits. So these are the circuit diagrams for star connected load and delta connected load. Here the single wattmeter is used. Single phase wattmeter, that is a single wattmeter is used here for the measurement of 3-phase power. So for star connected load, so in this case the wattmeter is connected in R phase. So current coil is connected in series with the phase. So whereas the pressure coil or voltage coil is connected, voltage coil is connected between the line and a neutral for star connected load. If you are taking for delta connected load, here also the wattmeter is connected. The wattmeter of a current coil. That current coil is connected in series with the line, in series with the phase, and the pressure coil is connected between that line and this load. So this is a connection of a star connected load and delta connected load. So single wattmeter is connected any one phase of a 3-phase balanced or unbalanced load. So here 3-phase balanced we are considered. So this is the way that wattmeter reading gives the, here in this one the wattmeter reads the voltage between the neutral line and current in that line, that is I phase, the angle between cosine angle between voltage and current. So this angle we are getting by the phasor diagram. By drawing the phasor diagram, we can measure the power in that particular phase. If you want to get a total power, 3 times wattmeter reading. 3 times wattmeter reading will give the total power in a star connected or delta connected loads. For that one, so next we will see 3 wattmeter method. So 2 wattmeter method already I discussed in previous lecture. So now going for another method, that is 3 wattmeter method. In this 3 wattmeter method, compared to single wattmeter method, in single wattmeter method only only one wattmeter is used, that we call a 1 wattmeter method. Here 3 wattmeters are using. So here we are using 3 wattmeters. For the measurement of power, we are using 3 wattmeters in 3-phase circuits. So 3 wattmeters are used. So this method is used for balanced as well as unbalanced load. So this 3 wattmeter method is used for balanced as well as unbalanced load. So here in 3 wattmeters are inserted in each of 3 phases of the load, whether they are connected star or delta connected. So the loads may be connected in star or delta. Here the 3 wattmeters, each wattmeter is inserted in each phase of a 3-phase balanced or unbalanced load. So here each wattmeter will measure the power consumed in each phase of a 3-phase load. Here if you are considering for balanced load, the wattmeter readings, W1 and wattmeter reading W2 and wattmeter reading W3. So these 3 readings are same for balanced load. Whereas for unbalanced load, the readings of wattmeters W1, W2, W3 are not equal. For unbalanced load, the readings of a wattmeters W1, W2, W3 are not equal. For balanced load, the wattmeter readings in each and every phase, that is W1 and W2 and W3, all are equal. So the total power is given by adding the all three wattmeter readings W1 and W2 and W3. By adding three wattmeter readings, so we will get the total power in a three-phase balanced or unbalanced load. Either it may be a star connected load and delta connected load by using 3 wattmeter method. So this is a connection. As I said that, so each wattmeter is inserted in each phase of a load. Here wattmeter 1 is inserted in R phase, wattmeter 2 is inserted in Y phase, wattmeter 3 is inserted in B phase for star connected load. Here how they are connected? Every current coil of every wattmeter, this current coil is connected in series with the line W2. The wattmeter W2 is also, the current coil of a wattmeter 2 is also connected in series with the line. So wattmeter, the current coil of a W3 is also connected in series with. That means that current coils are connected in series with the line. Whereas the pressure coil of each wattmeter, for example, you consider the wattmeter W1. This is a pressure coil of a wattmeter W1. So this is connected between the line and the neutral for star connected load. Similarly, the wattmeter 2, pressure coil of a wattmeter 2 is connected Y phase, between Y phase and neutral. And similarly, the pressure coil of a wattmeter 3 is connected between B phase and neutral of a star connected load. So this is the way the wattmeters are connected in each and every phase, and pressure coil is connected between line and neutral. Similarly, if you are considering delta connected load, so in every phase, if you are considering R phase, so this is R, this is Y, and this is B phase. So in each and every phase, one wattmeter 1 is connected in R phase. So here also the current coil is connected in series with the line. The pressure coil is connected between these two lines. Similarly, wattmeter 2 is connected. The current coil of a wattmeter 2 is connected in series with the line. The pressure coil is connected between these two lines. So here wattmeter 3 is also, the current coil of wattmeter 3 is also connected in series with the phase, and the pressure coil of a wattmeter 3 is connected between these two lines. So this is the connection, how they are connected in each and every phase. One wattmeter is connected that measures the power in that particular phase. So here next we will see how we are measuring the reactive power for a balanced and unbalanced loads. So for the measurement of a reactive power, so only here also we are using single wattmeter is used for the measurement of reactive power in three-phase balanced as well as either it may be a star or delta connected loads. So we know that the reactive power formula, the reactive power is given by √3 times VL IL sin phi. So this is the formula for reactive power in general. So reactive power in balanced three-phase load can also be calculated by using single wattmeter. As I said that, so for the measurement of reactive power in three-phase circuits, we are using only single wattmeter. Single wattmeter is used for the measurement of reactive power in particularly three-phase loads. Balanced three-phase loads, we are using only single wattmeter for the measurement of reactive power. So here we can see in this figure, so this is a wattmeter connected in R load. So here the connection is different from 1 wattmeter method and 2 wattmeter. Compared to 1 wattmeter method and 2 wattmeter method, the here for the measurement of reactive power, the wattmeter connections you can see in this diagram. Here 1 wattmeter is connected in R phase. So here this is a current coil of a wattmeter, this is a pressure coil of a wattmeter. So here the current coil, wattmeter current coil is connected in phase with a line, R line. Whereas the pressure coil of a wattmeter for the measurement of reactive power, it is connected between another two lines. So it is connected between B phase and Y phase. It is not connected in R phase. So only current coil is connected in R phase. The pressure coil is connected between another two lines, that is line B and line Y. So between the phase Y and B, pressure coil is connected. In R phase, current coil is connected. So here the formula here is, so we need a VYB. So VYB is nothing but a line voltage. V by V is nothing but a line voltage. This can be written as VYN, the voltage between Y phase and neutral, minus the voltage between B phase and neutral. So this is a voltage across a pressure coil. So to measure this one, we need voltage between Y phase and neutral minus voltage between B phase and neutral. So this can be, we will calculate. So here in 120 degrees, so if you are taking VRN, VYB and VBN. So these are the voltages. Voltage between R phase and neutral, voltage between Y phase and Y. So this is voltage between Y phase and neutral. This is voltage between B phase and neutral. So for each voltage, there is a 120 degrees phase shift in a three-phase circuits. So similarly, so for this is a case for inductive load. For inductive load, the current is lagging with respect to the voltage. So this is a current in R phase lagging with an angle of phi. Similarly, the current in Y phase, IY, is lagging with an angle of phi with respect to VYN. Similarly, the current in B phase, IB, lagging with respect to VBN with an angle of phi. But we want VYB because the pressure coil is connected between Y and B phase. So this can be written as VYN minus VBN. So here we have VYN. So we need minus VBN. So extend BYN. So you draw one vector or one phasor opposite to VBN. That is nothing but a minus VBN. This is phasor of minus VBN because this phasor is opposite to VBN. So by combining these two vectors, VYN minus VBN, we can get VYB. So this is the voltage we need to measure to find the voltage to measure the reactive power. So this can be written as like this. So this is the line voltage. So here, so wattmeter reading can be written as, wattmeter reading is given by the voltage between V by B and current in R and cos of angle between V by B and IR. So here V by B is nothing but a line voltage. So R is nothing but a voltage in R line. Cos, so what will be the angle between V by B and IR? So this we will get from this one. So V by B and IR. So this is the angle. So this angle is nothing but a 90 minus 5. So the same thing I written here. 90 minus 5 is the angle between voltage V by B and line current R. So this will give VLIL sin phi, where cos 90 minus 5 is the minus sin phi. So this is the above expression multiplied by root 3. So if we want to get a three-phase power, three-phase reactive power, so we need to multiply root 3 times VL IL sin phi. The units are volt ampere reactive. Volt ampere reactive. So this is the way. That means that, so if you are multiplying wattmeter reading into root 3, you will get root 3 times wattmeter reading VLIL sin phi. So volt ampere reactive is the units of a reactive power. This is a way to measure reactive power in a three-phase circuit. In particularly, we are discussing for a balanced three-phase loads. For balanced load, so I am taking the reference from a Google. So here, this is the today's lecture. So that is the measurement of an active and reactive power in a three-phase circuits. So those are nothing but a 1 wattmeter method and 3 wattmeter method. In the previous class, I discussed about 2 wattmeter method and effect of power factor on a measurement of an active power. So thank you all.